Hello, this is Michael Stern. I'm a photographer, author, public speaker, and radio host. Some of you listen to my podcast on a regular basis at buildabetterphotograph.com. I greatly appreciate you spending the time to listen to what I talk about with my guests, and the mailbag, and the tech talk tips, and the product showcases. This is the sensor and meter calibration test that I talked about on show number 10. This is the follow-up I promised to make it a little bit easier to follow. Sometimes it's hard to do it on the show. So in this test, I'm going to calibrate and measure the speed, or perhaps measure and calibrate the speed of my sensor and the accuracy of my in-camera reflective meter. The first thing we have to do is make sure that we're in the right conditions to perform this test. And the conditions are the Sunny 16 rule, which states that in the right sunlight conditions, your ISO is X and your shutter speed is the reciprocal of X at f16. So whatever ISO you pick, and in this case I picked 250, which is a whole number, as a fraction is 250 over 1, and there's reciprocal is 1 over 250, or a 250th, the aperture is f16. If I was at ISO 50, the shutter speed would be a 50th of a second at f16. The exposure equation is the ISO and the shutter speed are identical at f16. The shutter speed is the reciprocal of the ISO at f16. There's lots of ways to express it. It's called the Sunny 16 rule. Between the hours of 10:30 and 1:30 in full bright sun, no fog, no smog, no atmospheric condition of any kind. It's very, very important to get this part of the step correct. These are known provable conditions, and this is the best way to perform this test so we know we have the light energy at a measurable value. Now you can see in this light meter, this screenshot of a Sekonic L758 meter, that the ISO and shutter speed are 250 and the aperture is 16.1, and it's reading at 16.1 because I have the meter set to tenths of stops, but this is close enough. How do we know if we're in the right conditions? Put your hand out about a foot off the ground, and if you see a very dark, hard-edged shadow, then you are in the right conditions. It's got to be that. It can't be a soft-edged shadow. It's got to be fairly rich and dark. Also, the sun is at your back. So the subject is facing the sun. They're wearing something white with a texture. In this case, I'm using terry cloth. It's very important because we look at white with detail numbers or printable values in order to dial in the appropriate exposure. So this first shot shows us we're in the right conditions. Now I shoot a bracket. I'm going to go down to 2/50th of a second. So this is the exposure at the conditions. I also shoot slightly darker by a third. This is 3/20th, and 2/3 of a stop darker at 400. I also go up to 200th of a second. I open up again to 1/60th and open up to 125th of a second. Sensors tend to run a little bit on the slow side, so if you're going to run this bracket, run it and put a bias towards the overexposed side. Now again, this is the exposure that should have been correct. We are in the Sunny 16 rules, and you can just tell by looking at this that it's too dark. Now I went and measured the numbers, and you can see right here that where between the red circles I've measured the numbers, and you can see that they're fairly low. For purposes of inkjet printing or printing to a web press or printing photographically, the white with detail numbers, you want them to be in the high 240s, just around 250. Used to be in the early days of inkjet printing, we picked a number that was around 242, 243. As printers have gotten better at printing, the numbers can go higher. I look for my white with detail numbers in the 248, 250 range. These are subtle white. The texture is minimal, but the texture is definitely there. So at the known conditions, we look at the numbers and we see how low they are. Opening up a third of a stop, these are the numbers we like to see. High 247s, high 240s, low 250s. It's a touch high on the blue channel, but it's still workable. There's detail. There's plenty of detail in the red and green channels. Now these three sets of numbers represent the values in the red, green, and blue channels in your digital file. This is additive color theory. It's based on starting with something dark and adding light to it. And there's a red, green, and blue wavelengths of light that are mixed together, and the composite of those three channels creates our photograph. So that's what these represent. It's always RGB, red, green, and blue. Blue tends to be a little bit higher in this case. It's still a printable range. And look on the far left, the shutter speed is at 200. So we had to open up the exposure value plus 1/3 of a stop to get to the right numbers. That tells me that my chip is 1/3 of a stop slow. So when I work in AV mode or TV mode or manual mode, I have to add 1/3 of a stop. When I'm in manual mode, I'm going to add that when I get the needle in the middle of my screen at 0, assuming I'm pointing it at something that's middle gray, I have to add 1/3 of a stop, either slow down the shutter, open up the aperture, or increase the ISO. Any one of those three will get me my plus 1/3. If you go back to some of the earlier shows, shows 3 and 4, we talk a little bit more about that. If I'm working in AV or TV mode, I set my exposure compensation to plus 1/3, and that will take care of the sensor issue. Now, I'm using the data color spider checker target in this case, not only to see the colors and how they change, but the target's nice and big, and voila, you can flip the color targets around and you have this nice big grayscale area, and it makes doing these kinds of tests a snap. Now, again, I'm in the known conditions. Sunny 16 rule, I have my ISO set to 250, I have my meter set to spot, so it's just measuring that area that's within the red circle, and I should have gotten a 2/50th of a second when I have the needle in the middle, because I'm reading a known middle gray value. And look at the shutter speed, it's 320. And the meter thinks that that gray is brighter than it is, and it's causing the exposure to be underexposed because it thinks it's looking at something brighter than middle gray. This should have been the actual reading, a 2/50th of a second. So the meter is 1/3 of a stop off. This is what the meter gave me. This is what it should have been. And we add that into the exposure that's correct for the sensor, and we see that there's now 1/3 of a stop correction that we must provide because the sensor is slow, and 1/3 of a stop correction that we must provide because the meter is out of calibration. Now, can I get the meter recalibrated? Sure, I could send it in and get it fixed, and that would be fine. And you know, they make the camera, they pack it up, they ship it, it goes in a truck, goes in a warehouse, goes in another truck, goes in a warehouse, gets to the customer, shipped in UPS. It gets banged around. It's no wonder that the meters get off a little bit. It's not uncommon for 1/3 of a stop correction on a meter. And if this was more than 1/3 of a stop, then I'm going to send that puppy back in and get it fixed because that's just way, way too out of whack. But 1/3 stop I can handle. So when I'm shooting in manual mode, I have to add 1/3 of a stop for the sensor, and I have to add 2/3 of a stop because the meter is misreading. When I'm in AV or TV mode, I have to set the exposure compensation to plus 2/3. Not really uncommon to have that kind of a correction, and when I do everything correctly, these are the numbers I'm going to be getting in my highlights. And that's detail that's printable. Anything lower, and you can certainly go with a darker exposure, but your highlights are going to get gray. They're not going to be white. They're not going to feel like they're white. And anything higher, the numbers are so beyond the printable range. The upper limit in a digital file is 255. We get much high. There's nothing to print at that point. So again, this is what the meter it was reading. it's a third under. This is what it should have been. So there's my third stop correction. And then we have to add another third because the sensor is slow. So this particular camera is a plus 2/3 correction. You can buy the Datacolor Spider Checker chart at Datacolor, at Sammy's, at Calumet. They're about $129, I believe. It's a metal case. And then what's really cool about this is on the color part, there's a little fade checker on the lower left, that red box you see. And when these fade, you can replace the insert cards. It's a great tool. I highly recommend it. I appreciate the information and the stability of this product line. So have at it, folks. Please send me an email if you have any other questions. I'd love to hear your comments. I really appreciate you, again, as I said, listening to the show, watching the show, and good shooting. Take care. Till next time. See ya.